Now let's actually solve some of the application problems that we've looked at the setup for, and we're going to start off with some of our basic integer problems. Let's say that the sum of two consecutive integers is 85. We're going to look at how to solve that. First of all, we need to represent our integers. Again, using the techniques we discussed earlier, we'll let n represent the first integer. And since we're talking about two consecutive integers, we're going to let n plus 1 represent the second of the two integers. Now we say that the sum, which means take the two and add them, if the sum turns out to be 85, then we add them and set that equal to 85. We're going to combine our like terms, subtract off the constant, and then divide by 2. So since our first integer is a 42, our next one is bound to be a 43 because that is our next consecutive integers. Now sometimes, instead of talking about consecutive integers, consecutive evens, consecutive odds, they might discuss two numbers that are not consecutive even, odd, or anything like that, but they will give you a comparison. Alright, let's say for example that you have two numbers. One of them is 3 more than twice the other. Alright, so again we let the n represent the first of the two values. And it said one more time, the other one is 3 more than, which means add 3 to something. 3 more than twice the other one. So 3 plus 2n would represent your second value. They go on to tell you that their sum is 27. So again we set up an addition, n plus the 3 plus 2n, and we set that equal to the stated value of 27. Again, combining like terms, subtracting off the constant, dividing. We find that one of the numbers is an 8. To find the other one, we simply do what they said to do when they described the second value. We'll add 3 to twice that, and we have our second number. Now let's look at some different type applications. Let's look at an application where a certain value is increasing or decreasing at a constant rate. Alright, so let's say we had a shop where they were making candles. They currently make 60 candles per week. So current production is a 60 per week. They plan to increase their production, so they're going to increase by 8 per week. Now the question is, how long would it take to reach 132 candles? So how long is it going to take to reach that value? Again, we need to pick a variable. So let's let t represent what we're looking for, which is the number of weeks. And our equation will be current production of 60 plus 8 per week, which means 8 times the number of weeks, until we reach the 132. So we're going to subtract off the constant, similar to what we did before. We'll get an 8t equaling a 72. We're going to divide both sides by 8, and for that we get a 9. So it would take 9 weeks, increasing at 8 per week, to hit a production of 132. And again, anytime you have a situation where you have a current amount that's increasing or decreasing by a constant amount to get a final number, you can always set it up in this fashion. Initial value, or current value, plus whatever it's increasing by per period of time until it equals its final amount. So now let's look at another application. And let's switch gears with this application and look at some percentage type applications. We've already talked about how percent increase and how percent decrease works. Let's actually apply that. Let's say that I just got a raise, and it was a 7% raise. And with this raise, my current salary is $35,000. And we might want to know what was the last salary before the increase. And again, we're going to designate that with the variable. And your salary is going to be modeled by last salary plus the increase. Now your increase was 7% of that salary, and you have to remember to put that X in there. If that X is not there, the 0.07 only represents 7 cents, not 7%. And we set that equal to the current salary. Now at this point, we are now able to combine like terms. So adding and treating this like a 1x to a 0.07x, we get 1.07x equaling 35,000. We're going to divide off the 1.07. On the left hand side, that just gives us our x, and on the right hand side it's going to give us the previous salary, which if we take it to the nearest penny turns out to be $32,710.28, and again that is just a result of that division. So that is a basic example of how the percent increase works, and percent decrease works in a very similar fashion. Now let's look at one more application with percentages, and this time we're going to make it a percent decrease application. Let's say that Walmart has a 20,000 square foot store. This store is 12% smaller than the last store, and we want to know, well, then what was the size of the last store? Well, we will let X be the size that we're looking for, and the equation is going to be previous size minus 12% of the previous size, again like before. You cannot forget that variable, and we're going to set that equal to the 20,000. When you subtract, you get a 0.88x, because again you treat that like a 1x, and 1 minus 0.12 is 88, and that's set equal to the 20,000. We're going to divide by 0.88, and our solution is going to turn out to be, again rounding, our solution turns out to be a 22,727.27. So that was the size that we come up with for the previous store before it was reduced.